Today, let's start to look at derivative of a function. We are starting with this definition. This definition says, this is a derivative function. It says, let f be a function. The derivative function denoted by f prime is the function whose domain consists of those values of x such that the following limit exists. Meaning, the derivative, what am I saying? We say, let f be a function. The derivative function denoted by f prime is the function whose domain consists of those values of x such that the following limit exists. Meaning, the derivative is equals to the limit of f of x plus h, f of x plus h minus f of x all over h as x approaches 0. This function, f of x, is said to be differentiable at a if f prime, that means finding the derivative of f, then substituting a, exists. More generally, a function is said to be differentiable on S if it is differentiable at every point in an open set S. And a differentiable function is one in which the derivative exists on its domain. If it is clear to everybody, now let me request you to work out this. Oh, okay. Before I go to what I would request you to do for me, let's briefly talk about this. They say we use a variety of different notations to express the derivative of a function. For the function y equals to f of x, each of the following notations represents the derivative of f of x. F prime of x dy by dx, y prime d by dx of f of x. All are just saying, representing the very same thing, the derivative of f of x. Remember the definition that we just spoke about now, a few seconds ago? Yes, no?
Yes.
Thank you. Now, please use that definition to find the derivative of this function f of x, which is equals to x squared minus 2x. The time is up.
Done.
Done. Who is done? Who's talking?
It's Patience.
Patience, how are you, my sister?
I'm fine, and you, sir?
I'm good. Please share with us what you found to be an answer.
2x minus 2.
Please talk to them.
Hello, guys.
Hi, Patience.
Hi, girl.
For the solution for the problem that we have given, I got 2x minus 2. Is there anyone who got a different answer?
I got the same.
Got the same
Okay,
answer.
thank you. Okay, thank you.
Thank you, Patience.
So we have a hand, Kimati.
Thank you, my sister. Kmate, we are listening.
Yes, I just wanted to say, and I got the same answer.
Oh, okay. Thank you. Kmate, please lead us in giving us an answer in the next exercise.
bafuna ukuthi ingene kahle imqondo.
Please mute if you are not talking to us. Okay, Martin.
Yes.
Okay. Please lead us in giving us an answer to this next exercise. We all agreed with patience that an answer that we were looking for was 2x minus 2. Now, using the very same definition, do we all see exercise 2.1.1? Using that
Yes.
very same definition, please find the derivative of f of x, which is equals to x squared. Mr. K. Mate, are you
Yes.
finished?
Yes, I'm done.
Okay, what did you get, my brother? Followed by Tobani and then followed by Patience.
I got 2x.
Spokesperson, what did you get?
I got 2x.
I also
Patience,
got 2x.
I agree with the 2x that you found. Now, exercise 2.1.5. Please use the limit definition of the derivative to find the derivative of f, where f of x is equals to 1 over the square root of x plus 5. I'm giving you 2 minutes. We didn't move much. You didn't lose much. This is what we talked about. Do you see this definition?
Yes, Prof.
Tobani?
Yes,
Okay.
Prof.
This definition says, let f be a function. The derivative function denoted by f prime is the function whose domain consists of those values of x such that the following limit exists. F prime, which denotes the derivative of a function f of x in this case, is equals to the limit of f of x plus h minus f of x all over h as h approaches 0. We are using this, we are applying this to the exercises that we have already worked on up to so far. This is one of the things that we also studied in metric.
Yes.
Yes. Yes. So we are just applying.
Yes.
We are just applying this in these exercises. So the exercise that we are looking at is exercise 215. The time is up. Anyone who volunteers to share an answer with us for exercise 2.1.5? Marcel, what have you got, my brother?
I have
You need to believe in what you are doing.
I have negative of root of x plus 5 over 2.
Hang on. What have you got? Please repeat.
Negative of root x plus 5 over 2.
Okay, let me reserve my comment.
Hello, sir.
Yes, ma'am.
I'm done.
Done. Thank you. Start with myself.
Hello, sir.
Hello.
No, I just wanted to say I'm also done.
Okay, let me start with Marcel. Marcel,
Yes, sir.
you said you got
Negative of root x plus 5 divided by 2.
Everybody, we listen to each other's answer. Yeah? Okay. Thank you, Marcel. I've captured that. In order. Next.
So I've got
Yes, Mark.
-1 divided by, all right, how do I say this? 2 times in brackets x plus 5 close bracket to the exponent of 3/2. You could also say that is the 2 times the square root of x plus 5 cubed.
Cube root.
Not cube root. So inside the square root, you have x plus 5 cubed.
I captured that, Mark. Next.
I'm in agreement with Mark.
Hey, is that spokesperson?
Yes, sir.
Thank you, spokesperson. Next.
I got, which is similar to, not similar, but rather the same as Mark. It's -1/2, and then open bracket, x plus 5, close bracket, 3/2. But I wasn't sure how to write it, so I also rewrote it as -1/2 times cube root of, sorry about that, it's -1/2 times the square root of x plus 5 cubed. So yeah, that's that.
Hang on, I got lost.
So
You mind
first, how I wrote it.
Your name again?
Sorry, it's a Smanga.
Smang. Okay, yes, man.
Yes. So I was saying first, I got it as -1/2 open bracket x plus 5 close bracket 3/2, right?
Mm-hmm.
Yes, and then afterwards, I sort of rewrote it as -1/2 times the square root of open bracket x plus 5 close bracket to the power 3.
Okay, I captured that. Another interesting answer. People, you are confusing me now. Okay. Where should I go? Okay, let me write this down. We are saying our f of x is equals to 1 over the square root of x plus 5. Are we together on that one? F of x is equals to 1 all over the square root of x plus 5. Are we in agreement?
Yes, sir.
Yes, sir.
Okay. Now, let's go where? We go to our definition. This is our definition. Do we agree? Now, when we get here, we will have f prime of x is equals to the lim as sh approaches 0 of f of x plus h. That means this will be 1 over the square root of x plus 5 plus h close bracket minus 1 over the square root of x plus 5 all over h. Are we together?
Yes, sir.
Yes, sir.
I repeat, this is the limit of f of x plus h minus f of x all over h as h approaches 0. Now, we'll have the limit as h approaches 0, open bracket, we'll have 1 over the square root of x plus 5 plus h. Do we agree?
Yes,
Yes.
sir.
Minus 1 over the square root of x plus 5. Are you with me?
Yes, sir.
That is
Yes,
our
sir.
f of x all over h. Now, in our numerator, we are now having, let me write here, we've got 1 over the square root of x plus h. I hope you are working it out with me, plus h over 1. LCM here is the square root of x plus 5 in the first term. Are we together? Square root of x plus 5 into square root of x plus 5, that will be 1. 1 times 1, this will be 1. Are you with me? Plus 1 into the square root of x plus 1 into the square root of x plus 5 times h. This will be h into the square root of x plus 5. That's for the first term. Are you with me?
Yes, sir.
Sir, can you please repeat that?
What should I repeat, my sister? Where?
The first term, I was supposed to write it after.
Who's talking?
Hunadi.
Hmm?
Hunadi.
Hunadi.
Yes, sir.
Hunadi.
Yes, sir.
Our f of x, our function is 1 over the square root of x plus 5. Do we agree?
Yes, sir.
Now, according to this definition, you see this definition 2.1.1, this one.
Yes, sir.
Now, we are finding we'll have the derivative of f of x. Simply, f prime of x is equals to the limit as h approaches 0 of. What is our f of x? Our f of x is 1 over the square root of x plus h. Okay? But then we will have that there is a plus h there. Okay? That's why I'm saying then we will have 1 over the square root of x plus 5 plus h. Are you with me?
Yes, sir.
Minus f of x. F of x is just 1 over the square root of x plus 5. We
Yes,
together?
sir. Yes, sir.
Now, Unadi, help me out here. You and I are now only focusing on f of x plus h. Now,
Yes.
our x plus f of x plus h is 1 over the square root of x plus 5 plus h. Now we need to simplify this. Okay.
Yes, sir.
We've got 1 over the square root of x plus 5 plus h over 1. We agree. Our LCM is the square root of x plus 5. Still with me?
Yes, sir. Yes, sir.
Now, let's simplify. Square root of x plus 5 into the square root of x plus 5, since our LCM is the square root of x plus 5, that will be 1. It will go once into itself, and then times 1, it will be 1. Plus, remember, we have got h over 1. 1 into the square root of x plus 5. It will just be the square root of x plus 5 times h. Meaning, for this first term, we have got, I'm repeating it here, 1 plus h into the square root of x plus 5 all over the square root of x plus 5. Still with me?
Yes, sir.
Now, we are still in the numerator. Minus 1 over the square root of x plus 5.
Yes, sir.
Now, the next thing in the numerator, the LCM for both these terms is the square root of x plus 5. Are you with me?
Yes, sir.
Now, this is what we are saying. We are saying the square root of x plus 5 into the square root of x plus 5 goes once. Multiply by the numerator, which will just be 1 plus h into the square root of x plus 5, close bracket, minus square root of x plus 5 into the square root of x plus 5 goes into itself once, times 1, then is 1. Are you still with me?
Yes, sir.
If we are still together, now, what is the numerator after simplifying? Plus 1 and negative 1 will cancel each other out. We'll be left with h into the square root of x plus 5 all over the square root of x plus 5. Now, this whole thing is divided by h, all over h, as h approaches 0. Are you with me on this one? Then, when we bring h above the division line, then it will be 1 over h. Now, when we multiply the h and the h will cancel out. And then what will we be left with? Hello, what will we be left with?
We are lost.
Amen. Who is lost?
Patience.
Patience.
Smile as well.
Who? Smart.
Yes.
And also Unadi said, hey,
Hey, Baba, how are you, my sister?
I'm good, thanks. How are you, sir?
I'm good. Okay, step by step. I don't want to lose you, okay? This is what I'm saying. Copy, do you see this? F prime of x is equals to the limit of f of x plus h minus f of x all over h as h tends to 0. Please copy it down. Do let me know after copying it.
Okay. Done this side.
Is everybody done?
Yes, sir.
Okay. Tobani, from high school, from matric. Tobani? Okay.
I'm here, Prof. I'm here.
Yes. Remember, you and I agreed that we did this in metric, eh?
Yes.
Now, we are taking this to that exercise 2.1.5. Yes. Here. Now, let's talk. You copied that equation. It says f prime of x is equals to the lim of f of x plus h minus f of x all over h as h approaches 0. Okay. Now, in the place of f of x plus h, what should we write, Tobani?
I think 1 over square root of x plus h plus 5.
Yes, sir.
Who's talking?
Patience.
Okay. What should we write, my sister?
1 over x plus h plus 5.
Patience. We are looking
Yeah.
okay, slowly, my sister. Our f of x is 1 over the square root of x plus 5. Okay?
Yes.
Now, in the place of f of x plus h, please listen to me carefully. I'm saying we are going to write 1 over the square root of x plus 5 plus h. Do you agree with me or disagree with me?
We agree.
Agree.
Patience.
I agree, sir.
What should we have in the place of f of x plus h? What should we have?
In a space of f of x plus h, we're going to
Yes.
have the square root of x plus 5 plus h. Or x plus
Can
h
someone
plus
please
5.
help Patience?
1 over what patient said.
Oh, okay. I've already written 1 over, but I forgot to say it. Sorry, thank you.
I think it is 1 over root of x plus 5 plus h.
Who just said that? Lerato.
Yes.
I agree with you. It should be 1 over the square root of x plus 5 plus h.
Plus h.
Close bracket, okay?
Yes.
At the beginning, we open the bracket, then we close the bracket, okay?
Yes, sir.
Next, minus. Lerato, what should our f of x be?
Yes, sir.
What would be our f of x?
F of 1 over root of x plus 5, close bracket.
Okay, Lerato, here is my question.
Yes, sir.
That definition says minus f of x, okay? We are done with f of x plus h, okay? Now we move forward. We say minus f of x. What should we write in the place of f of x?
In f of x.
In the place of f of x, what should we write?
I think in the beginning we said x is 1 over root of x plus 5, right? we said that x is equals to 1 over root of x plus 5.
F of x, not x, my sister.
Oh, okay.
Now, what should we write in the
F of
place of
x.
in the place of f of x? What should we write?
I think it's still 1 over root of x plus 5.
I agree with you.
Yes.
Now, you and I agree, okay?
Okay. Yes.
That is what everybody do you agree with that's Lerato, ne?
Yes, sir.
We agree, sir.
Yes,
We
we
agree.
We
agree.
agree.
Okay, thank you. I'm happy that we agree. Now, please simplify that numerator. We know that below, okay, before I continue, we will then have a long division line. Below that long division line, we have got that h. Do we agree?
Yes.
Yes, sir.
Yes, sir.
Yes.
Thank you. Now, here is my request to you.
Where's
Please
my pen?
we don't know.
I'm sorry. I'm sorry, sir.
Now, please, we agreed on the numerator. It's okay, my sister. We agreed on the numerator. Please simplify the numerator and tell me what you get. The numerator.
I got f of open bracket 1 plus h root of x plus 5 all over root of x plus 5
Continue.
minus f of 1 over root of x plus 5 close bracket.
Who's talking?
Lerato.
Lerato, please get rid of that F.
Oh, I should. The second one.
Yes.
Okay, sir.
Remember, do you understand why I'm saying that?
No.
My sister, minus, we have got minus f of x, okay?
Yes, sir.
And our f of x is 1 over the square root of x plus 5.
5.
Not x. F of x is equals to 1 over the square root of x plus 5.
Okay. Okay, sir. I understand now.
Thank you. Now, I agree with you on what you shared with us as being the numerator. Now, my request is to everybody. Okay, everybody, do you agree with what Lerato has shared with us as the numerator?
So
Yes or no?
Can you repeat the numerator
Can you
again?
repeat?
Okay. I got
Numerator.
f of open
Okay.
bracket.
Hang on, Lerato. Everybody, may you please listen to what Lerato is sharing with us as the numerator so that we can continue. Lerato?
Okay, sir. I got f of open bracket 1 plus h.
No longer F, my sister.
I thought you said the second one. Oh, also the first one.
Yes.
Okay, it's removed.
You
All right,
repeat. We
it's
want to hear the numerator.
okay.
That is what she's
It's
saying. She's sharing with you. Please be
it's
patient with it.
1. It is 1 plus h root of x plus 5 all over root of x plus 5 minus 1 over root of x plus 5 close bracket.
Please
Thank
ask them
you.
whether they heard you.
Sorry, sir.
Please ask them whether they captured what you just said.
Did you all capture what I said?
Yes, ma'am.
Thank you. Now, since you
Can I
captured what Lerato
explain
said,
this, sir? Sir, can I
sorry?
explain this?
Okay.
Like the LCM, maybe they don't understand when it comes to the LCM. It's like when you have 1/2 plus 1, you take the denominator of 2 as LCM. So the root of x plus 5 is like that 2, the denominator. I don't know if they catch me.
They must
Ah,
catch
that
you
was my
so
problem.
that you don't run away from them.
I was struggling. Like I was like yo when coming to the LCM. I was confused. Thank you.
Okay, all right.
Thank you, Lerato. Now, everybody heard what Lerato said. Now you know what is in the numerator. Please simplify it and tell us what you get. We know that in the numerator we are only having an h. Please tell us what you get after simplifying the numerator that was shared with you.
So I got a bit lost here. It's 1 plus h root of x plus 5 all over root of x plus 5. And I cancelled the root of x plus 5, the numerator, and the denominator of root of x plus 5. Is
Who's
it
talking?
right? Lerato.
Lerato,
Yes, sir.
please repeat. Looks like you omitted something.
It's 1 plus h root of x plus 5 all over root of x plus 5. So I cancelled
You
the
cancelled?
root,
Okay, I'm listening.
the root of x plus 5 of the numerator and the root of x plus 5, the denominator.
What are you left with?
1 plus h.
Okay. May I please come in?
Yes, sir. Please, I'm lost here.
You left another term there. You left minus 1 over the square root of x plus 5. Do you see that term?
Minus 1 over the square root. Oh, that
Minus,
one. I wrote it.
yes. You
It's
wrote
funny.
it.
Yes.
Then what did you get
1 plus
after
h.
simplifying?
1 plus h minus 1 over root of x plus 5. I stopped there.
No, my sister.
Yes, sir.
I agree with, in the numerator, I agree with 1 plus h times the square root of x plus 5. Okay?
Okay, sir.
That term that you left out, we will have the square root of x plus 5 into the square root of x plus 5. It will be 1 times that 1, then we'll have 1. Do we agree? So we'll have minus 1. There is a minus 1 that you omitted.
The minus 1. Oh, the LCM of 1 plus h square root of x plus 5 and 1 over root of x plus 5 are the same. I did not see that. Okay, let me rewrite.
This is what I'm saying to you.
Mm.
You had 1 plus h times the square root of x plus 5 over the square root of x plus 5.
X plus
Okay?
5. Yes.
Minus 1 over the square root of x plus 5. We are still simplifying. The next term, that f of x. Everybody, do you see what I mean?
Yes, sir. Can I explain to her, sir?
Yes,
way-
who's talking? Who's talking?
It's Mpho.
Please, Mpho.
Lerato,
Yes, Mpho.
you have your numerator as 1 over root x plus 5 plus h, close brackets, minus 1 over root x plus 5, right?
No, say it again.
Akere, Lerato, your numerator, it's 1
From
over, yeah, your numerator, the one that you stated to us.
okay.
Yeah, from there, you found your lowest common denominator as root x plus 5, right?
Yes.
Okay, so the way you can simplify it, you will say you have your LCD, which is root x plus 5, and then you will say root x plus 5 goes once into root x plus 5, where there's 1 over root x plus 5, and
Yes.
then you multiply it by that 1 at the top there, and then you'll get 1. Okay.
Yes.
And then plus h multiplied by root x plus 5. Okay.
No, this one I'm done with it. I want it from the second step.
Yeah, we go in there, Amos.
Okay, okay.
Yeah, after getting the h into root x plus 5, you have another part of the numerator, which is minus 1 over root x plus 5. So you'll also say, because your lowest common denominator applies to everything at the top.
Yes.
So you'll say root x plus 5 goes once into root x plus 5. Then you multiply by that 1. Then it will be minus 1 again. Did you get that?
Yes, I do get it.
Yeah, so the ones will cancel, and the root x plus 5 will cancel. We'll be left with h in the numerator.
Oh, the 1 plus this one cancelled plus h. Okay. I have 1 plus h minus 1, and the ones cancel. I'm left with h over root of
No,
x plus
h
5.
into root x plus 5. Don't forget that. H
Okay.
into root x plus 5 over root x plus 5 after the ones cancel. You
All right.
understand?
Yes, I do understand.
Okay. I know, so you can proceed.
I'm not proceeding. Mpho, please
Say.
wait there. Now ask
Okay.
your sister. Ask your sister. After taking the denominator, which is h, into account, please ask her what is it that she found.
What is it that you found, Lerato, after you have got your numerator?
The last one.
Yes.
H root of x plus 5 all over root of x plus 5.
As a numerator, ne?
No, the numerator is h root of x plus 5.
No, it's a numerator because it's all over h, and it's there, like everything, it's all over h.
Okay.
Lerato, you still remember the formula, Mos? Everything
Yes,
is
I
all
do.
over h.
Yes, I do remember.
Okay, so say she found the same thing that I found before cancelling the root x plus 5.
What is the final answer then?
What is the final answer, Lerato?
After cancelling the root of x plus 5 and the root of x plus 5, I'm left with h over h. Then it's 1. Is it fine?
Yeah, now I also got 1. I didn't substitute h with 0. I just said the answer.
Yes, the answer is 1. Where will you You substitute
No,
0.
I was looking at the limit of h approaches 0, I need to say. That's
I
why.
agree. Yes.
Yes.
But we don't have it. So our
Yeah.
answer should be 1.
1.
Okay.
Okay, Lerato.
Thank you so much.
Thank you. You are welcome. Is everybody happy?
Sir, I'm not happy. I didn't understand.
Your name, ma'am?
Patience.
Patience. Yes, I'm listening, my sister.
Sir,
Okay,
the things
okay.
that
Sorry for stopping you like that, Patience. All members, family members, may we please listen to what Patience is going to say so that we can be able to help her out. Patience, please come forward, my sister.
I don't understand. I got confused from like where like we start to find the LCM. So I lost it there, so I don't know how to proceed. I've
Are you
been trying.
referring to the
I've been trying to get the answer, but I don't get what they're talking about. I just got things that are very far from the answer.
let me do you see this? Formula 2.1.1.
Yes.
This one.
Yes, I can see it. I copied down.
Oh, you copied down.
I
Okay,
copied
thank
the
you.
formula down.
Now, okay, if you copy the formula down, then there's no problem. Then let's go where we were. We were here, okay. We have to
Yes,
use
sir.
that. We have to use that formula to solve this function.
Yes, sir.
Okay. This is what we are saying. That formula is saying f of x plus h. This is sorry. That equation says f prime of x is equals to the limit of f of x plus h minus f of x all over h as h approaches 0. Still with me?
Yes, sir.
Yes. Now, let's start, you and I. We do know f of x. Patience. What is f of x?
1 over square root of x plus 5.
Thank you. Let's look at the first part. The first part is saying f of x plus h. Are you with me?
Yes, sir.
Now, in the place of x, we will have 1 all over the square root of x plus 5 plus that h.
I'm with you. Okay. Yes.
Then there is a minus f of x, which is the next term. Okay?
Yes, sir.
What is f of x?
1 over square root of x plus 8. I mean 1 over square root of x plus 5.
That is what we will put in the place of f of x.
Yes.
Then we then have a long division line. Below it, we have got what?
H.
H. Then, please, my sister, simplify 1 over the square root of x plus 5 plus h over 1 and tell us what you get.
Simplify 1 over
1 over the square root of x plus 5 plus h and tell us what you get. We have got 1 over the square root of x plus 5, okay? plus h. Are you with me?
Yes. Yes, sir.
This is the same as 1 over the square root of x plus 5 plus h over 1. Do you agree with me?
It's the same
H,
as 1
h
over
is the
square
same
root
as
of
h over
x.
1. Patience.
Sir.
Can you just listen to what I'm saying? Then you will come with what you need to say, or what you are
Okay, sir.
thinking. What you think you need to say to me?
I'm listening, sir.
Okay, I'm saying to you, we are working out this thing piecemeal. The first term from f of x plus h is 1 over the square root of x plus 5 plus h. Are we together on that one?
Yes.
Now, this is what I'm saying. I'm saying we are now going to simplify this first, okay?
Yes.
Now, this is the same as 1 over the square root of x plus 5 plus h over 1. h is the same, that is h. In terms of a fraction, is the same as h over 1. Do we agree?
Yes, sir.
Okay. Now, we are looking for the lowest common multiple here between the first term and the second term. What is the first term?
First term is square root of x plus 5
1 over the square root of x plus 5. Do we
over
agree?
square root of x plus 5. Yes.
What is the second term?
H over 1.
H over 1. What is the LCM for these two fractions?
Square root of x plus 5.
Thank you. We will have that below the division line, okay?
Yes, sir.
The way we did in primary. Now, from the first term, we will have the square root of x plus 5 into the square root of x plus 5. We are dividing. It goes, the square root of x plus 5 goes once into the square root of x plus 5, which is the LCM. Do we agree? Then we multiply by 1, which is that numerator. Then we have 1. Are you with me? Are you lost?
I'm not lost. I'm with you.
Then we have got a plus sign in between. We write the plus sign. Then we have got h over 1. Then 1 into the square root of x plus 5 goes square root of x plus 5 times h. Then we have in front of the plus sign, we have got h times the square root of x plus 5. So,
yes,
in
sir.
other words, what we are getting from the first term is 1 plus h times the square root of x plus 5, all over the square root of x plus 5.
Okay.
Are you with me?
Yes, sir.
Then, after that, there is the next term there, which is minus 1 over the square root of x plus 5. With me?
Yes, sir.
Now, we need to have this 1 plus h times the square root of x plus 5 all over the square root of x plus 5. To it, then we subtract minus 1 over the square root of x plus 5. Then we simplify. Still with me?
Yes, sir.
Please do simplify and tell us what you get in the numerator.
In the numerator, I now get h.
How? Please explain to us.
Because when I check, like our numerator, the denominators of the two terms is x plus 5.
Hmm?
The denominator of like, okay, sir, let me start with this. our numerator, again, we have two terms, and then the denominators of these terms are the same, is square root of x plus 5. So I have said square root of x plus 5 as my denominator, and then agree when the denominators are the same, we just add the numerators or subtract. So 1 minus 1 is 0. So I left with h square root of x plus 5 over square root of x plus 5. So x plus square root of x plus 5 cancel with square root of x plus 5. So we left with h.
Left with h.
Yes.
Please continue. What do we have in the denominator?
H.
Please continue. Simplify and tell us what you get.
So the answer, h cancels h. So the answer is 1.
Thank you. Do we all
Thank you
agree?
very much, sir.
Thank you, my sister. You are welcome. Do we all understand how we arrived at that 1?
Yes, sir.
Everybody?
Yes.
Okay, can we
Yes.
continue? Okay, now where are we going? From here, there is this theorem that I need to talk to you about. Theorem 2.1.1. Where is it? Next page. Should be here. Okay. Differentiability implies continuity, is what this theorem is saying. It says, let f of x be a function and a be an element in its domain. Let f of x be a function and a be an element in its domain. If f of x is differentiable at a, then f is continuous at a. Clear? Is it clear?
Yes, sir.
What this theorem is saying?
Yes,
Okay.
sir.
Thank you. Now, if it is clear, may we please look at this together. Where is this? Okay. This is this example in this page. The next one, not this one. What is happening? Oh. Where is this example of mine? Still ahead. Okay. All right. Here we are. In this example 2.1.5. my request to you is that I'm requesting you to find a second derivative. We all know how to find a derivative of a function. Eh?
Yes,
The
sir.
derivative of the
Yes, sir.
derivative of a function using the definition that we just used. Okay. Now I'm asking you to use that very same definition to find the first derivative. Okay. Remember, from that definition is just f prime of x, which is the derivative of f of x, is equals to the limit of f of x plus h minus f of x all over h as h approaches 0. Now, my request to you is to say you use that definition to find the first derivative. After finding the first derivative, you use that definition again, meaning that formula. You apply it again to find the second derivative. Okay. Let me start in this way. Let me request you. Let's do it stepwise. Let me request you to find the first derivative of this function, f of x, which is equals to 2x squared minus 3x plus 1. Find the first derivative using that formula. Okay. This is what I'm interested in. I'm not interested in the derivative. I'm interested in you using that definition to find the derivative. When you say to me you found the first derivative for this function, I'm going to request you to explain to us all the steps, what we have been talking about, all these steps in the recent exercise. Do you follow what I'm saying?
Yes, sir.
After that, once we agreed, you only calculate the first derivative. After that, you tell everybody, everybody calculates the first derivative. When you are done with the first derivative, you tell us that, okay, you are done. Then we check the first derivative before going to the second derivative. May I please give you 3 minutes to calculate the first derivative for this function, f of x, which is equals to 2x squared minus 3x plus 1. I'm giving you 3 minutes.
Sir, I'm done.
Who's done?
Willie.
Really? Okay, I'll just...
Yes, I'm also done.
I'm also done. Patience.
Willie, Patience, who
Smangaliso.
else? Smangaliso,
Marcel.
Marcel.
Msamulo.
Ntamulo, why are you hiding?
I'm not hiding, sir.
Okay, just talk to us. If you are not talking for me, you are hiding. Okay, who else? Hmm? My sister. I can hardly hear you.
Dalva, can you hear me now, sir?
Hey, Dalva, what's wrong with your mic today?
I don't know, it's giving me problems these days.
Please try to... I don't know the advice that I can give you. But I'm hearing you from a distance. Are you using a laptop or a phone?
I'm using my phone, sir. My laptop is broken.
Yeah, just throw that phone against the wall and then pick it up.
So we've got Kmart, his hand is up.
K Mate, thank you, my sister. K Mate. K Mate, we are listening, my brother, before we proceed.
Yeah, I'm done.
Oh, you also done. Okay, thank you. Thank you, my sister. Now let's start with where should I go? Willie, please, you explain to us using that definition how each and every step of how you calculated the first derivative.
Okay,
Family
so,
members, please, let's pay attention.
so first of all, I calculated f of x plus h, which like I got like 2x squared. Okay, I started by substituting 2 into x plus h all squared minus 3 into 3 plus x plus h plus 1. Then after solving that f of x plus h, I got 2x squared plus 4xh plus 2x squared minus 3x minus 3h plus 1. Then I substituted into the formula, which is f prime of x is equals to the limit sh approaches 0 of like f of x plus h minus f of x all over h. Then I substituted my f of x plus h and the f of x. Then after substituting that, my f of x, I always make sure that it's always in the bracket so that my f of x plus h will like cancel the f of x. So after that, I got like the limit as h approaches 0, 4xh plus 2h squared minus 3h all over h. Then I took h as the common factor in the numerator so that it can cancel with the h in the denominator. After that, when like I take out the common factor, I got h into 4x plus 2h minus 3 all over h. Then h cancels with h. I got limit as h approaches 0, 4x plus 2h minus 3. Then I substituted h with 0. Then I got 4x minus 3. That's my answer. I'm done for f prime x.
Thank you, my brother. Please talk to them.
Did you all understand, or is there someone who is confused?
Must still continue to find the second derivative.
Who's talking? Willie,
Dumele.
someone spoke. Who?
Dumele.
So you said
Itumeleng.
I must like talk how I got the first derivative, right?
Yes, my brother. Thank you.
Yes.
Itumeleng.
Yes, sir.
Itumeleng. May
Yes, sir.
may I humbly request you to work out the second derivative using the definition for us. Meaning,
Okay, sir.
you will lead us in giving us an answer to the second derivative of this question using the formula. Okay, this is a continuation from the first derivative. We are using what we found into that definition.
So, sir, can I ask?
Yes.
If you are looking for the second derivative, where, like in the formula, will it be like like instead of f of x, we will put f prime of x.
Yes. 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 Mm-hmm. Mm-hmm.
So where then for f of x plus h, will it be like f prime of x plus h, or it's like f of x plus h?
Please come back again.
Or cause here we
In
will
the
be like,
place,
yeah, like I guess you said for like f of x, it's f prime x, right?
for f of x is f prime of x. I agree with you on that one.
So
Next
for
question.
f of
Mhm.
x plus h, what must we like put there instead of that?
Okay. Remember, my brother, f of x plus h. Okay. Whenever you see x, you will put what? X
X
plus
plus
h.
h.
X plus h. Yes. Okay, let me say this. In this case, you have got 4x minus 3. Okay. In other words, your
Yes.
question is to say now, what are we going to put in the place of f of x plus h? Okay.
Yes.
Okay, you and I agree that f of x plus h, in this case, it will be this first derivative, which is 4x minus 3. Okay. Now, your question to me is to say, now, what is it that is going to be f of x plus h? F of x plus h is going to be 4 into
X plus h
h
minus 3. Okay.
minus 3.
Okay, thank you, sir. So in the formula, we will write it as f of x plus h, not like.
You write it according to the formula, but then you know that you are using the first derivative.
Oh, okay, sir. Thank you.
Hang on. That's Willie.
Yes.
No. Otherwise, there will be an inconsistency here. No. Let me rectify this mistake. Remember, is the second derivative. Remember, in the first derivative, it is f of x plus h minus f of x. Okay?
Yes.
Now, for the second derivative, it is going to be the limit of the first derivative of x plus h minus the first derivative of x all over h as h approaches 0.
Yes, sir. Thank you.
Thank you.
Sorry, sir. Can you please repeat that?
Who's talking?
Smanga.
Smanga? Which part should I repeat, my brother? Okay, this is what I'm saying. Remember, when we get the first derivative of a function, we say f prime of x for the first derivative, f prime of x is equals to f of x plus h minus f of x all over h as h approaches 0.
Yes.
Now, for the second derivative is f double prime of x, okay?
Oh, okay.
Is
Yeah, that's what I
equals
also
to
wrote.
is f double prime of x is equals to the limit of f prime, the first derivative, f prime of x plus h minus f prime of x all over h as h approaches 0. Are we together?
I'm with you, sir.
Thank
Yes.
you. Thanks.
All right, sir. I'm done with that one.
Are you done with this one?
Yes.
I'm also
Okay.
done.
I'm also done.
All right. Let me
So we've got
request you.
Minente's hand that is up.
Who?
Minentle.
Minentle.
Yes.
Okay, thank you, my sister. May I humbly request that we hear out Minenhle, then we'll come to verifying the answer to the second derivative. Minenhle? 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 Minenhle is not talking. Then
Oh,
we
sorry, I
continue.
didn't realize my mic was off. Can you hear me?
Okay. Yes, we can hear you. Get closer.
Yes.
Please get closer to your mic as well.
Okay. Can I please take you back to the first derivative? Because I think I made a mistake, but I'm not seeing where I made the mistake, because for the numerator I keep getting, I'm left with 1. So I'm not sure where I'm making the mistake. So can you kindly go back to the first derivative?
We are focusing on this example 2.1.5, ne?
Yes.
Okay. Um. Okay, Minenhle, you are requesting me to go back to the first derivative, to how we found the first derivative, eh?
Yes, sir.
Yes. But let me ask you this question. Before I go to the first derivative, have you got it? Did you work it out so that when we get there, or before we go to it, is there any particular step where you got lost or you made a mistake that you need to verify?
I'm not sure where my mistake is, but I substituted into the formula. So for the formula, we've got f of x plus h minus f of x all over h. And then when I substitute for f of x plus h minus f of h, like everything cancels out and I'm left with 1.
Okay, hang on, my sister. We're finding the first derivative for this function. Ne?
Yes.
When we find the first derivative, we'll have f prime of x is equals to the limit of, please tell me what you have in the numerator. In your first step after substituting into f. Okay, let me be slow. Minenhle, we say f prime of x is equals to the limit of f into x plus h minus f of x all over h as h tends to 0. Okay, this is coming from the definition. All right.
Yes, sir.
Now, please take me a step further where you started substituting so that I can be able to help you.
So I've got 2x squared minus 3x plus 1, and then plus 1. And then I've got minus into 2x squared minus 3x plus 1. And then so all over h. And then I went on to say 2x squared minus 3x, and then I've got 2, and then minus, opening that bracket, I have minus 2x squared plus 3x minus 1. So now I've got 2x squared cancelling out minus 2x squared, and then minus 3x cancelling 3x, and then I'm left with, I've got that positive 2 minus 1, so I'm left with 1 over 8.
Okay, my sister. I do believe that you have got a pen and paper in your hand. Okay?
Yes.
This is what you need to have. From that definition, now you are applying this f of x, which is equals to 2x squared minus 3x plus 1. Now we are applying it into that formula. This is what we'll have. we will have f prime of x is equal to the limit. In the numerator, we will have 2 open bracket. No, in the numerator, we will have open bracket. Are you with me?
Yes, sir.
2 open bracket x plus h close bracket squared. Have you got that?
Oh, yes, sir.
Minus 3 open bracket x plus h close bracket plus 1 close bracket minus open bracket 2x squared minus 3x plus 1 all over h as h tends to 0.
Oh, okay. I think I can see where my mistake was, sir.
Are you sure?
Yes.
Won't you repeat that mistake again?
No.
Okay, thank you.
Thank you.
A number of people have worked out the second derivative in that order that you said you finished. Please share with us what you found as an answer for the second derivative using that definition.
All right, so I got 4 as the final answer.
Your name, sir?
I also.
Very Smangaliso.
Smangaliso. Thank you.
Patience, I
Next.
also got 4. Patience, I
Patient.
also got 4.
Thank you, my sister.
Spokesperson, I got 4 also.
Thank you, spokesperson.
Mhlamulo, I got 4.
Thank you, Nhlamulo. Okay. Sorry?
Really, I also got 4.
Ngwanele got 4.
Kwanele got 4. Willie also got 4.
Winnie also got 4.
Yes.
Who? Winnie.
Yes.
Oh, we have got Winnie and Willie here. Okay. Thank you. Yes. The second derivative, let me repeat before I step off it. I agree with the 4 that was found. Our formula will be say f double prime of x will be equals to the limit of f prime of x plus h minus f prime of x all over h as h approaches 0. Then we will then have the limit of 4 into x plus 8 minus 3, or it will be open bracket 4 into x plus h minus 3 close bracket minus open bracket 4x minus 3 all over h as h approaches 0. Therefore, after simplifying, we get 4. We get 4 after simplifying as h approaches 0. Therefore, our answer then becomes 4. I'm happy that we all got the same answer. There's no need for me to waste time by explaining it here. Let's go to this exercise. Yes. Using that definition, please find the second derivative for f of x, which is equals to x squared. Let me give you, is 2 minutes enough? 2 or 3? Which one?
3.
3. Okay, thank you. Anyone, please proceed.
For the first derivative, I've got 2x for the second derivative. I've got 2 as an answer.
Before I let you off the hook, spokesperson. Did you use that definition?
Yes, in both methods.
Thank you, my brother. Others?
Also, Vandele got
Yes,
for the
Kwande.
first derivative, got 2x, and then for the second derivative, I also got 2.
Thank you, brother. Using that definition, eh?
Yes, yes.
Thank you. Everybody, we agree.
Yes, sir.
That
Yes, sir.
Yes, sir, we agree.
as long as we agree that we use that definition, first derivative, we get 2x, and then second derivative, we get 2. I'm happy. Can we proceed?
Yes, sir.
Yes,
Thank
we
you.
can
Yes.
proceed.
Okay. Here, my request to you. Ntamolo. Oh, okay. Spokesperson? People.
Yes, sir.
Spokesperson, do you see number 1? Do you see number 1?
Yes, I see number 1.
What is the derivative of this function? F of x, which is equals to 6. What is it?
0.
Okay. All right. To simplify this whole thing, to simplify this whole thing, I heard you, my sister. To simplify this whole thing, do you see f of x, which is equals to 2 minus 3x?
Yes, sir.
Yes, sir.
May I request to give you how many? 3 minutes to work out f of x equals to 2 minus 3x according to that definition. Then we'll step off this section.
Okay, sir.
Only because the whole idea is just to test your application of that definition. So it is of no use for me to test you on this long list. So that's why I'm requesting you to work out only number 2, then, and it's only the first derivative, only the first derivative. Then we proceed. Winnie.
Yes, sir.
Have you used that definition?
Yes, I did, sir.
Thank you. If you did, please share with us your answer.
All right. I said f time of x is equal to f x plus h minus f of x all over h. Then lim as h approaches 0, 2 minus 3 plus, actually no, sorry, 2 minus 3 into x plus h minus 2 plus 3h all over h. Then 2 minus 3x minus 3h minus 2 plus 3x. 2 plus 2 and minus 2 cancels each other. Minus 3 plus 3 cancels each other. And then I'm left with minus 3 over h. Then minus 3. No, h and h cancels each other. And then I'm left with minus 3. That's my answer.
What is your answer?
Minus 3, sir.
Thank you, Winnie. Please talk to them.
Guys, do you agree with me?
100%.
Yes.
Oh, okay. Let me thank everybody for having attempted this exercise. Winnie, thank you very much for leading us. Now, let's the chain rule. It says, let f and g be functions for all x in the domain of G, for which G is differentiable at x and f is differentiable at g of x, the derivative of the composite function h of x is equals to the composite of f and g of x is equals to f of g of x. Now, what is the derivative of the composite of f of g of x? The derivative of the composite of f and g of x is given by the derivative of f multiplied by g of x times the derivative of g. And that's it. This is what I needed to talk to you about. Is it clear?
Yes, sir.
Clear.
Yes, sir.
We will get to its application. This is what I was only interested in sharing with you. To say this is how the chain rule in the composite in terms of the composite functions. Before I let you go, this number, okay. Now we are going back. Back. Hey, there's a mouse. Okay. Aha. Remember from high school. Even if you didn't do this in high school, don't worry. Theorem 2.2.1, it says basic rules. Let C be a constant. Let f of x be equals to C. Let C be a constant. Let f of x be equals to C. Then the derivative, the first derivative of f equals to 0. The derivative of a constant is 0. Clear? Can I step off number 1?
Yes, sir.
Thank you. Number 2, let n be a positive integer. If f of x is equals to x to the power n, then the first derivative of f of x is equals to n x to the power n minus 1. Remember, we were told at the beginning that there are many ways to write the derivative of a function. This is how they are expressing it here. Is there any question on what they are saying on number 2?
No.
No?
No.
Thank you. Now let's go to number 3. Number 3 says, let f of x and g of x be differentiable functions, and k be a constant. Then each of the following equations holds. Each of the following equations holds. The sum rule. The derivative of the sum of a function f and a function g is the same as the sum of the derivative of f and the derivative of g. In other words, the derivative of f of x plus g of x is the same as the derivative of f of x plus the derivative of g of x. In other words, if that function, if this function is j of x, then the derivative, the first derivative of j is the sum of the derivative of f of x plus the derivative of g of x. Any question on number 2?
No.
No question, sir.
No question? Okay. There'll be questions during the applications. Don't worry. I know. Now, difference rule. The derivative of the difference of a function f and a function g is the same as the difference of the derivative of f and the derivative of g. Okay? The derivative of the difference of the function f and g is the same as the derivative, is the same as the difference of the derivative of f and g. Therefore, if the function is g of if this function j of x is equals to the difference of f of x and g of x, its derivative is equals to the difference of the difference is equals to the difference of the derivative of f and the derivative of g of x. Any question on the difference rule?
No, sir.
No question, sir.
No,
Okay.
sir.
Thank you. Now, constant multiple rule. The derivative of a constant, c, multiplied by a function f is the same as the constant multiplied by the derivative. Now, differentiating this constant k, which is multiplied by f of x, is the same as k multiplied by the derivative of f of x. Any question on these basic rules?
No question, sir.
No question. Thank you.
No questions.
Thank you. If there is no question, then let me go somewhere. Please find the derivative of f of x. I'm giving you 10 minutes. But if you are done, you can just tell me that you're done. But I'm giving you 10 minutes. Because I noticed that there is a lot of work to be done in this one. But if you are done, no problem. Yes,
Excuse
someone
me,
is
sir.
talking.
It's Mangaliso here. May I ask, sir?
Yes.
Are we using the one of the first principle or just basic rules?
Basic rules, my brother.
Oh, okay, sir. And then, okay, second, I think with this one I found the answer.
Oh, okay. Yes, please share it with us because we want to go.
I think the answer is 0.
Please
Why
talk
I
to
say
them.
that? Wait, sorry, sir?
I'm saying please talk to them.
Oh, the reason why I'm saying the answer is 0 for this one is because f of x equals to pi squared, and pi squared is it's a numerical value, it's a constant. And remember that the derivative of a constant is 0.
I agree with you, my brother. Please ask them whether they follow what they followed you on what you just said?
Family members, do you follow?
Yes, we
100%.
we follow.
100%, my brother.
All right, thank you.
Thank you. Now, please take this one as a homework. This one, find the derivative of this function f of x, which is equals to 2x to the power 5 plus 7. Using the basic rules. Then this will be our homework, and then we will, or maybe should we just conclude? Should we just work out this one and then?
I also agree with you.
Do you agree with me?
Yes,
My
sir.
sister, I don't hear you. Who's talking? Your name? Hello. Okay, is there anyone who has got an answer to this f of x, which is equals to 2x to the power 5 plus 7?
Yes.
Yes, sir.
Yes, sir.
Anyone, please just share your answer with us.
10x to the power 4.
10x to the power 4.
10x to the power 4.
Yes. Yes, sir.
We agree.
Now,
Now,
100%.
the last one before we go will be this one. Okay, please find the derivative of f of x, which is equals to 2x cubed minus 6x squared plus 3 in less than a minute. When you are done, you can
How
just
did it
share your
say?
answer. Sorry?
Already done.
Done already?
Already
Done.
Yes.
Okay. In the form of a choir, what is the answer?
6x
Six
squared
X squared
minus
minus
12x.
X.
Okay, one person now, so that I can be able to capture it.
It's 6x squared
Mhm.
minus 12x.
Are you done? Or are you still continuing?
I'm done.
Done.
There is something missing.
Plus 0.
No, I'm joking. Thank you. Let me thank you for having worked out this, and then let's say tomorrow we'll start to talk about
Sir, are we done with the chain rule, sir?
the chain rule of the composite functions.
Yes.
We are not done. What I just did today, I just share it with you so that in the process,
Okay, sir.
when we will be applying it, you shouldn't be surprised, or you shouldn't be saying, but you never talk to us about the chain rule. That was the whole idea for sharing it with you today.
Thank you, guys. Thank you for attending. Let's meet each other tomorrow, and our mission will be accomplished.
Thank you, my boss.
All right.
Thank you, everybody.
Thank you.
And good night.
Thank you, everybody. Bye. Good
Nice.
night.
Bye.